Okay, so we've got four coordinates, P, Q, R and S. So I'm just going to plot these on a set of axes just to get a rough idea of where they are. So P is somewhere here, that's -2, -1. Q is somewhere up here, that's 6 and 3. R is 9 and 2, so it's probably somewhere here. And S is 1 - 2, so probably somewhere here. Okay. The key here is just making sure you're getting them in the right quadrant, but also at an approximate distance apart from each other. Just again, like remembering that if, wow, I've done something really wrong, haven't I? P shouldn't be there. Okay. So P should be -2 -1, that should be P. And S would be 1 -2, which is actually somewhere here. Alright, so okay, so then that means my graph actually looks, or not graph, sorry, the quadrilateral looks something like that. So like I was saying, the key is making sure that you get them into the right quadrants. So we can see from these that they must be in the right quadrant, but we know that on the y-axis 2 is lower than 3, and on the x-axis 6 would be before 9. So just making sure they're in the right areas, and just as I corrected my P and S here as well. Okay, so we want to find out what kind of quadrilateral it is. Now there's lots of different properties of quadrilaterals that we can use. But in this question, I'll probably start off with the gradient, because the gradient would tell us how many sets of parallel lines it has, if any. So let's start off with P to Q. So we'll do the gradient of P to Q. So that's y2 minus y1 over x2 minus x1. So that's 3 minus 1 over 6 minus 2. So that would be 4 over 8, which is a half. Okay, so this gradient is a half. So if you want, you could just label it on your diagram. So this is m is equal to a half. Let's work out the gradient from Q to R. So m Q R. Again, y2 minus y1 over x2 minus x1. That's 2 minus 3 over 9 minus 6. That's minus 1 over 3. Let's do the same for m R to S. So m is minus a third here. So again, y2 minus y1 over x2 minus x1 would be 2 minus 2 over 9 minus 1. Again, that's 4 over 8. That's half. And finally, S to P or P to S. That's y2 minus y1 over x2 minus x1 is equal to minus 2 minus 1 over 1 minus 2. That's minus 1 over 3. Okay, so far we've got here m is a half, and here m is minus a third. Okay, so from the diagram and from what we've just worked out, these two are parallel and these two are parallel. So we've got two sets of parallel lines, which suggests to us that it must therefore be a parallelogram. Okay, so we know P, Q, R and S is a parallelogram. Okay. All right. The other thing we could check is also, and depending on the type of quadrilateral you have, you'd have to check the lengths. So for example, if you had two sets of perpendicular gradients, it could either be a square or it could be a rectangle, and the only way you could check is by actually working out the lengths of the two lines. or the 4 lines that are there. So if you have 2 pairs of equal length, then it's a rectangle, and if all 4 lengths were equal, then it'd have to be a square. So just be careful when making a decision about what kind of quadrilateral it is. Alright, so once we've done this part, depending on the question, they'd like you to work out the area of this quadrilateral, okay? But luckily in this question, they're going to tell you that the next part of the question is basically, I'll just shift this over here.